Sätter mig nära här och fick så mycket skit. Nej, just det. Sitter längre bak. Vilken ful man.
Sitter bara igenom det.
Nej, inte oss tror jag.
Fan. Jag tror man kan...
Har du sett att det var en...
Jo, det är ganska bra. Men det är väl sådana här.
Vadå?
Hotwatch.
Jaha, nej, jag vet inte. Det liksom ligger och guppar i sista. Det finns en över som jag handlade den för ett tag sedan. Och så var det alla matcher. Så det gick inte.
Det är egentligen det lägsta du har aldrig sett. Jag var på väg upp 3.
Jag har varit 3, men också jag har varit så jävla högt. Tips är att sitta långt bak.
Man kan fällas det. Och så skulle jag hit också. Ska ringa någon som måste springa iväg.
Som är budar nu eller något?
Ja, vi får se. Fråga inte vad det blir.
Det var ju Hisingen.
Där kör vi gatan.
Men längst ut. Det är samma sak.
Frågar man kan man få det.
Man kan ha
Här.
lunchen.
Här bor jag. Lån eller inget. Det är bara svårt. Där bor jag. Jag känner lite bara suget lounge. Jag känner det är ju alltså i tal som går till course.
Should we get started? With your video? Yeah. So today I'm going to be talking a little bit about my experience writing JavaScript tests. So I've been through this process where I first started. I didn't know a lot about tests, and I only knew mostly about tests from the Java world. So I'm going to try to go through some of the things that I've learned in the process. So I think the best way to understand the problems is by starting with an example. So I'm going to start with something that happened to me. So I got to work early Monday morning. I pulled the changes from Friday. I ran the tests, and it doesn't look very good. And this is what's going through my mind, of course. So I don't think this is okay at all. So I started looking into this. And the thing is, Jenkins is green. So that means that when the last person pushed code on Friday, everything was actually okay. So before we go more into what happened here, we need to just have the basics of writing JavaScript tests. So this is a test written using Jasmine, which is one of the most well-known JavaScript testing libraries. We see up here that we call describe, and within describe we have a set of tests. And each test is here created with the it function. So within a cart, we have a test that calculates correct total price. And in that test, we create the cart, we add a couple of items, and then we can expect something. So in the end, we expect that the total price is equal to something. We also have before each and after each. So well known from the Java world too. And then we can also do something a little bit different, where we have a subgroup of tests. So the describe within the describe here is just a subset of the tests within this file. And the outer before each also works on the inner test. So outside we set up a cart. We then in the inner describe set up a couple of items in the cart, and then we expect something. So this is basically the things that you need to know about how tests look like in JavaScript. Going back to the example, we start looking through this to understand what's going on. So the first thing we can look at is basically the message here, basically the title of the test. It says that an order with life insurance, with child insurance validates. It's quite vague. It doesn't tell me much about what's going on. So if we look further, we can see that we expected something to be true, but it was false. It still doesn't tell me a lot. And then we can start looking through the stack trace. And somewhere within the stack trace, we find the file where this actually failed. So it says order spec.js, line 200. Okay, so we go into that file. And this is the test itself. So it says that it should validate, and then we expected an order to be valid. So we see that we have an order here, but what is the order? And basically the question is always, why did it fail? And now we have to go to the nearest before each to try to understand what's going on. So we go to the before each within that describe, so within that subgroup of tests. We see that we create a product. It's a child insurance. You know this when you work on insurance. And we add it to the cart. One problem here though is that we don't do anything with the order. We expected something on order, not on cart. So there's some strange stuff going on here. And again, why did it fail? We still have no idea. So we go one step up. There's another before each. And this before each was run for about 10 to 15 tests. And there's a lot of stuff going on here. We create a new product. It's a life insurance. We set some beneficiaries. We actually do some stuff with the order here. But still, this is getting tedious. And then we go to the main before each for the entire test. And I give up. This before each was run for 55 tests. And now people, when they wrote the code, me too, I was part of writing this, we thought this was dry, this was nice. But the problem is that when you're actually debugging this, it's really hard to understand. The problem in this case was this number. And I don't know if you have the same in Sweden, but in Norway, the social security number includes your date of birth. And the problem was that this policyholder got too old to have child insurance. So basically just failed overnight. And this is the point you start hating your tests. Because this took me at least half an hour to debug. And now your tests start costing you hours of time just basically debugging simple stuff. And this is why I think we need to learn more about how we actually write our tests, because it's very easy to go to do the wrong thing when you start out. So, but to understand more about how we should write them, I think we should understand more about why we actually do write them. And one good reason is that testing in production isn't a good thing. That's what testing in production. But it depends. And this is important. People tend to say that you should always do TDD, you should always do, it depends. So I think to understand my perspective on this, you need to understand that I'm a consultant. So I work in Oslo for a company called Beck. And I usually work in 5 to 10 person teams. And usually for like 3 months to several years. My current project I've been on in, I think, 2 years now. And it's usually for quite large companies on interactive and complex application. There's usually a lot of domain knowledge in these apps. And usually someone takes over for me. So one day I quit and someone else takes over. And or sometimes the entire team has a big bang takeover. So we lose the contract for the next round, and then some other company comes and takes over. that makes tests very important. And it's important that they're understandable, so people can take over and understand what's going on. So that's basically the introduction to my context in this. So I'm going to talk a little bit about philosophy and a little bit about techniques that I use when I test. And I should try to share some experiences that are both good and bad, where the starting example was really bad. For me, why do I test? Basically, there are three main reasons for me. I'm going to go through these in order. So first of all, regressions. And the thing is that we're now building more complex and interactive applications in JavaScript. This is a big difference from before. Usually we had big complex apps in Java or C# or something else, and we had reasonably small applications in JavaScript. Now we can see 50% of the project being JavaScript. It's usually in larger teams. At least for me before, I was one of the only guys on my team that did JavaScript. Now the entire team does JavaScript. And I want to be less afraid of changing code. So basically the same thing for Java but for JavaScript. And perhaps more importantly for me, I want to be less afraid of changing other people's code. That's at least a big problem when I'm new in a team. And I also think debugging in production isn't a good way to live. And lately I've been focusing a lot on fixing a bug once. When you see something, add a test for it, and then the next time something happens, you have covered that already. The next up is communication. And one thing that have been happening also lately in my team is this question: why did we do it like this? And we try to focus on getting this into the tests. The problem is that if this lives in a Word file somewhere, it's really hard to understand the specifics, because that's hard to write in a Word document. So 6 months down the road, do you remember all the details? Especially if it's a very domain-heavy application. If you work on, for example, in insurance, there's a lot of stuff going on there. And also, what should it actually do? Are you sure that this is not a bug, or is it maybe a bug, or what's going on? So usually there's a lot of edge cases. And the last one, design. If your test can give you immediate feedback, this is the main point for people focusing on TDD, is that it gives you immediate feedback. I'm not big, TDD can work and TDD can fail, but I think immediate feedback is a good reason to test. And it also helps keep the code simple, and that's a really positive thing. If your code, or if it feels painful to write the test, that's usually a sign that there's something that needs to happen with your application code. So basically, that's my three reasons. And this might sound reasonably simple, it's just write some tests. But the problem is that it's really easy to write bad tests. And that was the first example. That was my initial approach to writing JavaScript tests. And it didn't work out well for me at all. So, I'll try to go through the steps that I now try to focus on when I write my tests. The thing is, these are the things that how I try to write my tests. And that's an important thing here. It's not necessarily how I did it, because this is a continuous approach for us too. But first of all, we try to focus on the reader, especially now that the team is larger than before. This becomes more important. Because now, usually my time spent reading code is greater than my time spent writing code, especially when fixing bugs or when adding new functionality to the things that someone else has written before. And in a team setting, I tend to spend a lot of time reading other people's code. And so we want everyone to be able to participate on most of everyone else's code. So we're not too focused on having that one person in the team. I try to stay away from setup, basically before each we saw and after each that we saw in the beginning. So try to keep that just as little as possible and focus on not doing much stuff in there. You shouldn't have a lot of stuff happening in a setup. And the main reason people tend to, or me too, tend to go this route is that a lot of people talk about dry, we need to dry up our code. And usually we then try to move this code up into the before each, and we then call it dry. We don't repeat anything, that's good. But the problem is that it's hidden code. When you look at your tests, you don't know what to call it before, you have to go looking for that code. So I think that dry isn't always the answer. We need to separate between drying up lines, so just this line is repeated somewhere, and drying up concepts, so focusing on what's a concept. Usually, before each ends up being 5 different things, doing 5 different, working on 5 different things in your application. So I saw this quote some time ago. Basically, your test should be a tiny universe with minimal conceptual overhead. And that was the problem in the first example, is that you don't have this minimal conceptual overhead. You actually have to go looking for things and remember what you saw earlier. So that makes it really hard to understand what's going on. And especially if there's a lot of code that isn't necessary for this specific test. When we saw the before each, the last one, the big one, in the beginning, that was for 55 tests. So you need to go looking for which part of that before each actually is doing something that helps or creates a bug in my test. So we shouldn't be that afraid of some duplication, especially in our tests. So usually, for me, instead of creating before or having things in my before each, I use creation helpers. And it's basically just JavaScript functions. So here it's the same test. So here we see the same line down here. That was in the initial example. But now we see that I can create an order, and I also create a cart, and I create a policyholder. And I also say that the age should be 14. Instead of having this social security number that you need to understand that the reason it's there is because this user should be less than 15 years old. So now I have some functions that are actually doing some of the things behind the scenes. But this makes this test really easy to read, and everything about this test is in this, or everything you need to know to understand the last line is within this test. And this is also the test when it's over 50 or 50 or more, and then it's false instead of true. So I think having creation helpers with good defaults is a good way to go. Then you can focus on what's different in this test. And I also try to reveal intent. One of the essential issues with the example we started with was that I didn't understand why didn't it validate, and it was really difficult to understand the goal here. And therefore, it was really difficult to debug because I didn't necessarily understand why it should validate at all. So basically, if you ask, I try now to ask this question before I push a new test. What am I actually testing? Can I understand that from the test itself? And in this case, I can't. And focus on why, not how. It's really is to get focused on what you're writing instead of why you're writing it. And deterministic, this is precisely the issue we had in the first test. Every time a test runs, it needs to have the same result. Otherwise, we have to go looking for these numbers in our tests. And that makes it really hard. And it's difficult to understand, did it fail only now? For example, you see that often with the tests that have a lot of date stuff. They can fail like, okay, so it's 29th of February. Okay, it fails today, but it's okay tomorrow. So we accept that tests fail sometimes. And that's not it's not a good place to be at all. Because then you suddenly start accepting tests that shouldn't fail. And another thing is just keeping the tests simple so they're easy to understand. as soon as you start having conditionals for if while loops and things like that in your tests, it becomes really hard to understand the flow. So let's just say that we're going to have some kind of data creation. So we have a timestamp for events. So we wanted to say midnight and noon, and then otherwise AM, PM, because it's always hard to understand, is 12 PM noon or midnight, at least if you don't live in the countries that use AM, PM. So one way of writing this could be something like this. So this, basically, we loop through all the minutes of the day, and then we create the day, we create events with that day, and then we start checking. So is it midnight, is it noon, or is it AM, PM? The thing is, there's a bug in here, and no one has been able to see this bug before. But the thing is here, the bug is actually that up here, this is actually so year, month, day, hour, minute, seconds. So we put it in the wrong place, but the tests run. Because now we only loop through the first 24 minutes. So we could actually have a bug here, but we wouldn't know. But everything appears to be okay. Instead, if we go the route with some of the things I've been talking about, we will maybe do something like this instead. So we have a create date helper where we can say hours and minutes. And now we are sure that these are actually run, and they're really easy to understand. I think this is far easier to understand than this. Because this, I have to go, okay, there's a for loop. It's looping through something, and then just start working through it. And also having pre-expects like this makes it really hard to understand when it's called and why is it called. For example, this is never called. How would we know? Is there any way of, we don't have any way of saying that if some expect is not called, we should fail the test. Because this expect is called 23 times, and no, 1 time and 23 times. So. And another thing is the more functional a code is, the easier it is to test. So if you have no dependencies except what you give it as a parameter, it's easier to test your code. If you have a function that takes 2 parameters, A and B, and you do something on A and B, and don't use any other dependency, some shared state or something, it's easier to test. Especially now, you will always have the same, or the same input always gives the same output in this case, and it's far easier to reason about why that happens. Another thing that is especially important in JavaScript, where we don't know a lot of things from Java before, is the importance of separating the DOM from your logic. And especially if you use, for example, jQuery, when we start testing JavaScript, usually we had big jQuery apps, and they're really hard to test. But if you try to focus on separating these two, it becomes really far more simple to test. So this is basically what I try to tell my team. So I've been using Backbone, Angular, and React, and other things on my projects. And I always try to focus on getting code out of these places. Have a pure JavaScript function that takes 2 parameters and return a result. And then you can test that thing by itself. If you do some date stuff, do that in a separate file and require that file into your Backbone view or directive or whatever. So pure code is easier to test. And it's actually quite important, especially in JavaScript, to see code fail, because everything in JavaScript is asynchronous. And in tests, that might be hard to see that some. We can show that by an example. So here I have some test that runs. So I have some player, it should increment the count when the song is finished. So here I do, let's see, we create player, we expect the count to be 0, and we then play a song, and then when it's finished, it should be 1. Okay, so now I refreshed it. And I try to change it to 2, and then we'll refresh it again. Everything works. 3, still works. And the thing is that we need to tell it that we're finished. And now if we refresh, it will actually tell us that it failed. Because the thing is, this actually failed all the time, but because the test was finished running, because JavaScript is asynchronous, the test didn't have anywhere to tell us that it failed. So if you open the dev tools and see them in the console, you would have seen something about the test failing. But this showed everything as green, and your build would work, and everything would be fine, and nothing would necessarily work. So asynchronous tests always need to tell when they're done, and this is the main reason that you actually need to check that your tests fail, because this is the most important thing your tests do. If your test doesn't fail, you basically failed writing tests. So they can help with design, they can help with communication and things like that. But if they don't fail when they should, that's a bad thing. And also they shouldn't fail when they shouldn't fail. So for example, it should be deterministic. So the date example we started with, that test shouldn't fail. It's important to focus on when and why tests fail. So beware of these async tests. And another one, especially when people are getting started, if you've been working in Java, you know this from before. But this is what I try to do when people on my team start writing tests. Just have them write out, okay, first I arrange something, I create a cart, and then on this cart, so I add some items to it, and then I assert. So if you, in the beginning, keep the comments, it makes you focus on actually doing this. Because if your test only have this step, that's a sign that you have too much stuff in your before each, or too much stuff outside this test. So you should at least see arrange and assert. You might not have active if you're checking on the initial setup. And I do prefer to have one aspect per test. Otherwise, people end up having this if and for loops and other things. So just try at least to focus on having one and accept that sometimes there will be more. So I always try to follow this pattern. Just the new person on my team have to write it out. And then, most importantly, and it's basically what we've been talking about, is that tests should be stupidly simple. They should be, I don't know, unnecessarily simple. They should be really to understand what they're doing and why they're doing it. Because the thing is, when we don't understand our tests, we tend to go the route where we started today, having to debug for 30 minutes when it's just a simple number that was off by 1 hour. I know this is basically what we should try to focus on. And if you're going back to a test later to debug, and you realize that it was your tests, and it feels like a pain to debug them, that's a good sign that we should be doing something. So I try to focus on writing tests that I'd be happy to debug myself. And I'm not still always happy when I have to debug them, so there's a lot of work on work to get this right. So that's basically about how I try to write my tests. I'm going to talk a little bit about how I try to maintain them. So how I work with my tests after they have been written, because that's at least as important as writing the test, is actually maintaining it. Because if you have poor quality tests, it can slow you down. So that's what happened if you have a test that I had in the beginning. You just end up deleting them because they just slow everything down. And you need to treat your tests as you treat your application code. So we always refactor application code, but I don't see a lot of people talking about refactoring tests. And we should feel the pain. If it doesn't feel good, that's usually a sign that something isn't working. And do refactor them. And you're also allowed to delete tests. That's okay. If the test doesn't give you value anymore, just delete it. Because the problem is that if you get to, usually before, I used to talk about how many tests my project had. So I could say like, okay, we have 700 tests, or we have 3 times the more tests that we have lines of application code. So you have like this 15,000 lines of tests and 5,000 lines of application code. The problem now is that you have 5,000 tests that you maintain, that's basically your application, and then you have 15,000 lines extra that you need to somehow work with. So that means that you have to maintain them, you have to refactor them, you have to keep them clean. You need, when you do changes here, perhaps big changes, you're changing an entire feature to do something else, you need to do a lot of stuff over here. So we have a lot of code to maintain now. So I don't think focusing on this as a metric is not a good thing. Focusing on getting value from the tests, that's a good thing. And perhaps a lot of you know who Martin Fowler is, but I think this is a good basic idea. So instead of just focusing, we need to have all the tests in the world, focusing on testing the most difficult parts of your application. In the beginning, that might be testing a lot more than you would after 2 years, just to get started with it, especially when you're getting started with writing tests for JavaScript. It might be helpful to start writing a lot of them, and then after a while maybe delete some of them because they don't give value anymore. They're just taking up your time. And yeah, I think we need to focusing on both the cost and the value when we have tests. We started just focusing on, we need tests and we need more tests and we need to do TDD and we need to do a lot of things. But the main reason that we test is the value we get from them. And then we have things like handling regressions, handling communication, handling all of these things that I talked about in the beginning. But the main thing is just connecting the cost with the value and then seeing what this value actually is. Because I think there's a lot of value in tests, but there's not a lot of value in bad tests. And that means that we need to learn. And there's maybe some dogma in what I've been saying, but don't focus so much on the dogma. Don't test because someone told you to test, and not focusing on the amount of tests. Instead, focus on writing beautiful JavaScript tests. Make them really good and make them give you value. And I think this is the main, or I think this is the place where JavaScript isn't entirely, we're not there yet. The tools are okay, not very good. And also we don't know very much. There's still not a lot of good resources about JavaScript testing. So basically we're still learning how we actually should write good tests. But just don't accept things that you can't understand. And try to keep them simple. And I think that tests can actually be awesome. And this is what we're trying to do now. Experiment more about how we actually write them. Because there's a big difference in how we look at it. I see that it's difficult to give specific advice on how they should look like, because it's very different writing tests for Angular and writing tests for Ember and React and Bekkelund. They're very different, but the core ideas are the same across all of them. And especially for all of these, because all of them are focusing on how we handle the DOM, and all of those 4, they don't do the same thing with the DOM. They have different philosophies about how we have it. That makes it hard to show specific good examples on it. So how can we actually increase the value? I think that's a good thing to think about. So just for me, at least, what do I see as a beautiful test when I write tests in my project as a consultant? And here, there's a big difference between libraries and applications. If we write libraries, we write tests in an entirely different manner from applications. In applications, there's more state, there's more domain logic, there's more stuff going on. And I got no definitive answers, but these are basically the most important things for me. I want to have really fast tests. They should be able to run in at most a couple of seconds. And they should fail when there's actually something wrong, not when I've written a bad test. they should be understandable. Also, when I go look at someone else's code or someone else looks at my code. So that means revealing intent, showing what you actually tried to say, and focusing on the reader. And otherwise, there's basically the same points that I went through in the talk. And I think that we should focus on the craft, not the tools. So it doesn't matter what's the best JavaScript testing library out there, because first of all, there is none. And the second one is, it doesn't really matter, because you can choose the best library and write bad code. And you can choose the worst and write really good tests. So the important thing is just focusing on how to actually write them, how they work in our projects. So I think what we did in my team was that we talked a lot about them in the beginning. So we started writing tests. So that was for my first JavaScript testing project 3-4 years or something ago. And we had this timeout where we basically took the entire team. We were 4 people at the time. And we took this like an hour, a couple of times during the year that we had the project. And we just talked about how did the test look? Does it feel good? And we often do this after something failed when it shouldn't fail, or when something just didn't feel right. And we also you need to run them in your build. You need to run them in Jenkins or whatever. So treat them like you treat your Java tests or whatever else tests you have. And also the last one, I think you should just fail your build. Don't accept this that okay, your build is yellow or something. If your test fails, it should fail the build, I think. At least then you handle it straight away. So if you want to learn more, there's some general purpose things here. Like this one is the examples are Java. That's a really good book. And this is also, I think the example in this one was also Java. But this is a pure JavaScript book. And this is really good. This is actually very, very good testing book, no matter what language you're working in. And I also always mention this talk because it was an important talk for me to try to understand how I want to write my applications. So it's not a talk about testing, but it's a talk about how we should write our tests and how we should about how we should write code. And it's a really good talk. And Richie is an awesome presenter. He's the guy who made Closure. Yeah, I think that was it for me. Thanks. If you have any questions, you can just ask me afterwards. I think that's easiest.
Yes, as a gift, thank you. We'd like to use this wireless speaker called Professor from our sponsor, Neuroscience.
Thank you. And if you want to work in Oslo,